Hi, welcome. My name is Michael Lange, and today we're going to be building a custom GPT. Now, what these are a new platform but developed by OpenAI that allows you to slap some of your awesomeness on top of the ChatGPT platform. We're going to be building one end to end. We're going to be using ClearML for our ML ops. We're going to train and deploy our models. We're going to be building our API, and we're going to be tying it all together right here. Now, the idea for this what this does is it takes an input string and determines whether that essay, specifically an essay, is written by a large language model or a human. Now, the idea came to me last year when this contest came out from Kaggle called LLM, Detect AI Generated Text from the Learning Agency in Vanderbilt University. And I entered and had a lot of fun with it. But as I was developing, I started thinking, one, I know OpenAI developed a tool a couple years ago, I believe, that did the same thing, and they took it down. I'm guessing because false positives are tough, right? I mean, you write something, and the machine says no, it was written by a large language model. That's tough. So my perspective on this was whether the response was accurate or not, you really have to explain why the forecast was generated. So I did all that. And here is the proof of concept right here. I want you to check it out. I'll put all these links in. And this is basically the notebook I developed for Kaggle's contest. And it explains the architecture, how I developed everything, how I put it all together, and how I developed all the training data. It's good stuff. But let's get to demoing our product really quick before moving on and seeing how it really works. Now, I'm going to just chat and ask questions about it. And let's see, generate an essay about GPTs and test the API. You know, it's alpha, and so all right. So let's see what happens here. Interesting. It's our essay. Let's hit the API command. Sure, take your time. Oh, should we just? It's all right. It's all right. I wonder if it'll say this is human or not. I probably should have had this already, but I like the idea. All right, let's hit it. It's kind of neat because then we can analyze the text and see what it came up with in our response. And let's hope it doesn't break because this is live, obviously. You never know. And it's hitting my local machine here. I've got it running an ngrok. Okay, so it probably loaded up the API a little bit long. It took a little bit longer to generate the call to my API. But now it's calling, so it's generating the forecast and all the features that were used to generate that forecast and return it back to the GPT, so the GPT can look at those features that were used to generate the forecast and explain them. This is a process called retrieval augmented information or generation. Anyway, so as you can see, the model I'm using, just kidding. So this is good. So it's one, it was written by a large language model, so at least this is accurate. And the training data for this demo was 1,000 records. It's nothing. So I did not expect it to be wrong. But as you can see now, some of the features that I used to generate this forecast are sitting in here. This is nice. So now, okay, so these are, and then I did a lot of statistical features. This is cool. All right, I'll let you read that and test it on your own. So basically, what it's doing is it's giving us a value and determining and in the response, it's explaining what it generated and you'll see how all this works in the next videos. But I just wanted to review this for you right now. Let's find out a little bit more about how this works before we move on. Let's talk about the model used to generate the demo forecast. And I spelled everything wrong. See? Basically, this is it's a BERT model, the bidirectional encoder representation of transformers, and then I have the PyTorch model of that. So it's a BERT model with a few long short-term memory layers slapped on top of that. But they make it sound really good. And this is in the knowledge file that I gave the not this, but it's like I gave the code, because something like this has to be open source, right? When you're determining whether a large language model was used to generate your essay, someone's going to ask, how was it generated? How was that forecast generated? And if you don't have the code and the data to back up any kind of forecast you have, it's just not worth anything. So we can ask our GPT, where is the data that was used to generate the forecast? Hopefully it gives us the right info. We shall see. Yeah, there we go. It's a good sign. So the Persuade corpus, I've got a link. Hopefully it gives you the links. And then I generated a data set, and I give you the code to how I generated the data set for the AI generated. Provide links. So you have them. Private URLs. Oh no, I don't want those. Oh, look at that. Oh. Even the private. That's not good, actually. If somebody types in, I want the private URLs, you shouldn't give it to them. but this is good. This is my repo that I set up for this. So, and all the code to do anything in this demo is right here too. Now let's ask about one of these features. Just so, because let's talk about this one, semantic density, because these are standardized scores, and you see some of these, but then I generated a lot of these statistical features. And the model I used to do the forecast on the statistical features was an EBM, an Explainable Boosting Machine. It's from InterpretML. It's a Microsoft interpretable software. It's an additive model. Really cool. I don't want to. I get into a lot more of that in the demo, but I first want to just show you this here real quick. Explain how semantic density is calculated. Related it here. I can't spell. Okay, cool. This is good. It does exactly that. I did provide it the code. Yeah, so we don't do that. But we do use a BERT model in the code. See, now this is kind of an error, interestingly enough, because I have a specific function that calculates semantic density, and I provided that function and an explanation of it in the features overview, and it should have known to look at the knowledge base for that. But let me see if there's anything I want to talk about before we move on and get this show on the road, because it's a lot of work to do. I built the whole thing in this demo, and like I said, all the code that we're going to be using for the demo is provided right in here in this little GitHub repo. So please check it out and let me know what you think. And good luck. Please stick with it. It's a couple hours long, and it's a lot to do. It's probably won't work for you the first try, because you got to deploy a bunch of Docker containers and do all this stuff. There's a lot of setup to do. But using ClearML was a lifesaver. I can't say enough about that MLOps tool. It really provided for me the ability to go from a general idea here to a platform that I can use and deploy and put everywhere. I'm not using the Kubernetes Helm charts to deploy all this, but I do use Docker Compose, a lot of cool stuff from ClearML-Serving. So I can't say enough about that. Anyway, good luck, enjoy this, and stick with it. You're gonna have a lot of fun, and you're gonna learn a lot too. All right, thanks. Have a great day. Hey, welcome back. It is time we build. There's a lot to do and fun to be had, so let's start having it. Okay, so what have we done so far? We've reviewed the product that we're going to be building. That is the AI Human Custom GPT, and that takes an input string, determines whether that string was written by a large language model or a human, returns that classification along with a bunch of other information to explain the classification it produced. We looked at the models used to determine that classification. We looked at the feature matrix used to determine the EBM classification, as well as the Retrieval Augmented Generation to explain why we classified it a certain way, and then ClearML and how it's just an awesome tool. All right, so we're going to make this easy on you. We're going to, you're going to download a GitHub repo and then start following along with me. And the first thing we're going to do is set up our environment. Then we're going to deploy our infrastructure. We're going to train and publish our model. We're going to deploy our API. We're going to create our GPT, and then we're going to smile. Sounds like a lot, and it is. It's going to probably take you all day. The video shouldn't be very long, because once we get things going, I'm going to have to pause, because training takes hours, and setting up all the Docker stuff takes a while. But let's just move along here. All right, so I want you to first open up your terminal. Whatever you use is cool. I'm using Warp just so I can have the command saved here and execute them on the go. We probably won't do much of that anyway because I'm going to probably not be that. It won't be that easy to just start executing commands as much as I want it to be that easy. Okay, so let's clone our repo first. I made a folder called demos, so I'm going to clone it right into there. I'm going to CD into that. And I'm going to open this up in Visual Studio Code. Or you can use whatever IDE you want. I'm using it here. The first thing I'm going to do is go to Presentation and Prereqs. I'm going to view that. I know I'm going fast, but you can slow the video down if you'd like. But just remember, if you get to here, you don't have to worry about slowing or stopping or this or that. I'm literally going to be following every line here. And yeah, obviously you're going to be able to see what I'm doing, but you won't miss any commands. So the first thing we're going to want to do is we're going to want to set up ClearML. And I'm done with the presentation part of this, so I thought that was that. It was exciting. But so sign up for free, ClearML, clear.ml. Click free sign up, make it happen. You need an account to get things going. Unless you set up ClearML server completely separate, it is an open source product, but that might take a little bit longer. It's definitely doable. It's not that difficult, but I recommend just setting up a free account so you can use all the online tools and not have to worry about configuration and all that stuff off the bat. Test it out first, then set up your own when you need to. But they also offer a lot of value-added features that are cool. We'll get into that later, maybe. So once you've set that up, you're going to go here, boom, and do these first steps. Click this, install it, make it happen. And then once you're done with that, we'll start following along. So we're in our folder, we've opened our repo. Let's do ClearML init. And we should have it already configured. When you do that, you're going to get some different commands. Here, you're going to set all that up. And then we go to the next step. Make sure you install Docker, get it going. Docker Desktop is what I'm using. You can use whatever you want to orchestrate your stuff, but just make sure Docker's installed. You're also going to want to, what did I do here? Ngrok. Ngrok is your tunneling software. In order to test APIs or third-party APIs, or let third-party APIs integrate with your local host development machine. Usually, you need a tunnel, so they can hit up an HTTP address on the internet. And Ngrok allows you to create a tunnel from your local host to Ngrok servers, and then your code being served in a sense from Ngrok via HTTPS to the API user. Hopefully all that made sense, but it does. Ngrok is pretty straightforward. Okay, now that you are set up with all the setups, you've got ClearML, you've initialized it, you set up Docker, you set up Ngrok. Now let's get to work. Okay, so first step first, we clone our project. Now we're going to create our Conda environment. This is important. Some people don't do this, and I never understood why, because I've run into so many problems trying to install everything in Python in main, or not main, but in your regular root Python installation. Anyway, this creates a virtual environment that allows you to work. I use Conda. It's cool. You could also use VNV or VVENV. I think it's Conda, Python virtual environment, but I like Conda because it does a little bit more. It seems to just work a little bit better. Don't know why. Don't have any proof of that, but it's just whatever you like to use, So we're going to create a Py39 demo, and we're going to use Python 3.9 because it's just the last, I think, major release of Python that everything kind of worked with. So here we go. It's I've already got it installed, but I'm going to just continue to move forward. So it'll remove it and then reinstall the environment. So as you do that. Okay, so yes. See how long this takes. When we okay, so let's activate our environment here. Okay. So now we're working with it. Let's just make sure that on the environments list. And then we'll see, make sure we're activated on Py39. And okay, so that starts letting us know we're good. So next, we're going to want to install our packages for our environment. I know I should be doing this. Actually, I'm going to do what you're doing. Copy off of this, just to make sure everything's working the way you are. I know there should be version numbers and all this, but I actually tried that once or a number of times, and I did it from my inference container was running on Docker. I looked at every version number that was installed to get everything to run, because most of these are installed for the feature generation that we'll get into in a second. But it needs all these to determine all the statistical stuff and whatnot. But anyway, I kept getting errors. Some things weren't downloaded. I just stopped working through it, only because this worked without installing any version numbers. It kind of figured itself out. If you can get it right without any version numbers, or if you run any problems, do what you can. This is always one of those. Python's a beast when it comes to this kind of stuff. So just be careful. Do the best you can. All right, so let's install everything here. Hopefully it takes a while. I want to show you some stuff. Let's go in here. Open up your project real quick, or whatever you're looking at, whatever ID you're in. Let's review some of the things that we're going to look at real quick. The ClearML pipelines is code that I use for the proof of concept notebook that we reviewed earlier. This is just pipelines to do the test data generation that I created for the big model, and the feature generation pipeline. We won't be using any of this stuff. This code we will, but not this code. But it's part of a different project that's more robust than this one, and I wanted to make sure that you still had how it was being done anyway, so you can work off of that. These are the models that are a little bit bigger than the demo model that we're using now. Not so much bigger, but just have a little bit more features. Like this does optimal fine tuning, and it retrains based on that, and does a bunch of trials, and does hyperparameter stuff, and and the same with EBMs, which we're not actually going to fine tune here or train here, because we don't need them for this demo. We're going to generate one model, determine the classification. We're going to generate all the features that we use to do the EBM classification, and just return those instead of trying to do the classification and return those as an ensemble. It works, trust me, it does, but we're just not going to for this demo. And this is just all the info for the original proof of concept. I recommend getting into this and just looking at where my brain was and every step of the way, and where the ideas came from to generate those features that we created. A lot of research, a lot of fun. It was just neat learning. And the test for the API. We're going to be working mainly off of these guys right here. This is just the full notebook. Pull this up anytime, read through it, have a laugh. This is the model that we're going to be training and uploading to ClearML, or it's going to automatically upload to ClearML and used for our inference. We don't need to worry about this, other than we don't need to worry about it. This is the demo that we're looking at now. We don't need to worry about that yet. This is the pre-processed file. This is pretty much our API. We're going to take a look at this pretty soon, or when we get to this point. It's going to be neat. ClearML-Serving, we're not going to touch. This is from ClearML. This is their product. This is actually a fork of this repo. But I added a bunch of stuff onto it, and I'm not actually going to merge back into their stuff. But since it's so tightly integrated, it was a good idea to do so, I believe. This is all our Docker stuff. We're going to use Docker Compose Triton, and I'll show you all that when we get there. And some other examples that came with ClearML-Serving, and we're not touching those. RGPT, which is these guys, the knowledge file privacy policy and Swagger. If you've ever made one, you know exactly what I'm talking about. If you haven't, we'll get into all these goodies. And these are the presentation files that we're going to be looking at right now. And some of this I don't think you need. Maybe this was a long demo. I don't know. I'll delete all this before you look at this, probably. So just ignore what you don't see. So let's see where we're at. All right, so we installed everything. Look at the next thing on our list and see where we go from here. All right, so this is the fun part. We've got to install the Berkeley Neural Parser. Don't ask me why, but I will tell you when we get there. Oh yeah, I'll ramble on. Okay, so we're going to do that. We just need it for some of the feature generations that we're doing. Like when it actually runs the feature generations, these models are needed to, generate them. All right, and then we need Spacey Large Language Model Web, or Spacey EN Core Web Large, because you need large to work the Berkeley Neural Parser. All right, so let's just make sure we got that installed and downloaded. Okay, we don't. Good sign. Okay, and then we're done with that. We're just going to keep moving along. Okay, you are now done. We're going to move on to setting up the infrastructure. Hi, welcome back. And we've got your content environment set up, and now it's time to configure and deploy your infrastructure. And by infrastructure, I mean everything that you need to deploy your API, run it, deploy your models, serve inference, and all that good stuff. And what we're going to use for that is ClearML-Serving. And what ClearML-Serving is a model orchestration and deployment tool for ClearML. It's a great piece of software. It gives us all the pieces of the pie that we need. We're not going to get into everything right now because it would take too long, but what we're going to do is, as I use features for ClearML, I'll explain what they are and what they're doing, obviously. So the first thing we do with ClearML is we install it. So let's go back to our terminal, pip install ClearML-Serving. Bam, I should have it installed already. I do. First, let's make sure we're working out of our regular content environment. I know, but if you open up a new terminal, you might not have worked back into your environment. So make sure you are activated in Py39 before you start writing code in here. And some terminals, like iTerm, will say, conda activate. If you do conda activate in here, it'll say PyTorch, or not PyTorch, but what environment you're using. But here it doesn't for whatever reason. But so here we go. Let's now that we've installed, we're going to create a service. So what this is it is an ID that is created. It is a service ID that you use to basically tie everything together, tie your models together, tie your inference containers together, and all that good stuff. Your pre-processing files, those containers. So what we're going to do is we're just going to create the name AI for AI or human demo. So create this right here, AI or human demo, and then write down the ID that it generates for us. You should have configured everything when you, like, this should work fine because when you did ClearML init and ran through all that stuff, you set up all your configurations. Good, and you're tied into with that, with those secrets, with those secret files and stuff that you generated. So write this down. And this is the ID that we're going to use to tie everything together. And first things first is, let's go back to our project and look at what we're going to do next. So we've installed and we've created our serving service. Now, write it down, which we did. Now we're going to look at the Docker Compose file. We got to change a couple things in here. We got to change one thing. Actually, we don't have to change anything. I've already changed it and put it in the repo. But just so you know what I'm talking about, let's take a look at it. So actually, let's look at this first. Let's look at our environment, our example environment. This is the ID that we just generated here. We're going to want to put into that file. Okay. And as you can see here, I have my API access key and my API secret key right here. These will probably be regenerated by the time I show this demo, but yeah, whatever. Don't use them. So we're good to go there. So we're going to save our file. Now we're going to take a look at Docker Compose Triton. The reason we're using Docker Compose Triton is because we're going to be serving up a PyTorch model, and Triton is actually an NVIDIA interface for inference. Beyond that, I'll let you research it, but it's a great tool, and I'm really thankful that ClearML got it all configured and ready to go for us. It's a heck of an addition. It makes us look like a pro. So what we've got here is extra Python packages that we're going to install for our inference container. These are the things that our inference is going to need and our pre-processing is going to need as well, which includes all those things that we installed into our virtual environment. So you don't need to change anything here, you just have to look at it. know that there are things there that can be changed. All right, so now we go back to here, and we don't have much more to do than spin up our containers, and that's going to take a hot minute. So we'll let it do its thing. Actually, let me read what I wrote down here. So we're using Docker Compose, or if we're running on Kubernetes, use the Helm charts. That's actually pretty cool. I'm not going to get into it right now, but I'll show you how that all works in a second. We're deploying a PyTorch model, so hopefully I said this stuff. Yeah, so we want to use the Triton inference server, which is made for GPU. We use CPU because I'm working on my laptop, but it doesn't matter. It still works on my laptop. In production, like I said, we're going to use K8s and the Helm charts, and that's all right here. But anyway, so here's our command to spin up these containers. And as they spin up, we'll review what's being actually installed on our machine. This takes a while because it installs all this Docker containers, images, and sets everything up. So as we run this, I'm going to pause it, go have some din, come back, and we're going to finish the project. We train our model next. And after we train our model, that's going to take a little while. But after that, we'll come back and create our GPT. So let's spin this up. So what we're doing here is we're jumping into the Docker folder. Excuse me, sorry. We're jumping into the Docker folder. We're hitting the environment file, and then we're running the compose up, the Triton compose. And as that runs, things start happening. Now, what's neat about this, if you open up Docker, you see your containers, yeah, things have already started. They're quick. So we got stuff going. Seconds. All our containers have already been downloaded, or they're downloading and installing them as we speak. Let's take a look real quick at ClearML. You haven't gone into here yet, but I invite you to. So this is good stuff. So this is the ClearML dashboard. I just don't have the time to review everything, so we're only going to look at specifically the things that we're doing. So we're going to go into our MLOps project, or DevOps project. And we're going to see that we've spun up a statistics container. This is Prometheus. You can see everything being run right here. Well, look at that. Kafka, broken. Well, because everything's trying stuff at once, don't get nervous when you start seeing errors right now, because things just aren't downloaded and installed. Because, Kafka needs something else, but if it's ready to go, it's going to run that. It's all asynchronous is what I'm trying to say, but things always retry and work and whatnot. So you won't get anything broken when you're doing this process. At least you shouldn't. And this is our Triton inference service. This just kicks it off and starts running. There's nothing going on. This just keeps running the whole time. This is fast. Our ID, that's a good sign. So we look at the configuration. We don't need any hyperparameters for this. Look at our properties. There's nothing here. Actually, what's interesting here is all our code gets written up too. So this is just a heck of a utility. So I'm going to let this run. I'm going to pause things now, and then I'll come back and show you all the stuff that we've done in the process, or in the meantime. All right, see you in the view. Thanks. All right, now that we've got our Docker container spun up, let's make sure it's good to go. The best way to check right here is, where you're running your Docker up command or your compose up command is find ClearML-Serving inference and then find the results page. That means everything's been installed. We're good to go. It's running and cool. So let's take a look at what we've done here. If we log into, actually, let's first log into Docker Desktop and take a look at what we've got going on here. We've got all our goodies deployed. We are going to have to actually install a couple things. We've got to go to ClearML-Serving inference container. This is the inference container that's going to run our pre-processing file. And pre-processing file generates all our features, which includes the Berkeley neural parser and the spacing model that we forgot to install in the Docker Compose. So let's go into here, go to execute. I already did it just because I wanted to make sure it worked or not. We're going to do it again here. Let me just make sure I have the right command. Actually, this is going to be a Python, not 3. I don't know why I put that there. Okay, so first thing first, we're like we did earlier, is we're going to install the EN Core Large Web for Spacey, because that is needed to use the Berkeley neural parser. So if you go into Docker, you can go and execute commands right on Docker containers that may be missing your stuff. This is kind of important. It's good to know how to do this too, because you're not going to get everything done sometimes on your Docker Create or your Docker Compose, stuff like that. But you can always use this file that's been deployed as a new Docker image. So when we redeploy this, we'll probably create the, not in this demo, but we'd create a new container that's based on these things being installed and use that for our inference, so we don't have to do it every time. But let's install this right away. So let's get these installed right into our Docker container, so when we run our inference, it doesn't break. Let's grab our other command. This downloads and installs the Berkeley neural parser for our statistical tree features. Exactly that. Okay, where are we? Where are we? No, we're in Docker. It's happening. So when this is done, we'll take a walk through some of these things in Docker as well, but we don't want to go too far into it because we might get lost. Anyway, we'll get there when we get there. I just don't want to get too off topic because we got a lot of code to write, or at least a lot of things to consider and run, or configure and run. All right, so we're good to go there. Now we're going to do this one. Thank you. Glad I can do that. Now we're going to install the Berkeley neural parser and download the one we need, BinParth EN3 for inference. Now once we're done with that, we're going to go right to our model and take a look at the changes we're going to need to make. Well, we're not going to need to make any changes, but we're going to look at what has been done to get it to deploy to ClearML. Basically, it's this right here. Right here, when all our model is trained and run and saved, it saves the model to our folder, creates an artifact out of it. This uploads it to the configured ClearML task, which is then going to be tied to our ID for our serving inference container. It sounds kind of complicated, but it's really not. So the things we got to look at here is the first thing. Inside the main function, we create our task. Okay, so this is the things you're going to want to change when you configure your model. You want to, and you can leave them the same actually, because you're using a whole different ID, your account, all that good stuff. So you won't say anything on my ClearML server, obviously. But you can change that stuff if you want. And then if you create a model with ClearML or using ClearML, you want to do argument parsers for all your arguments, so you can connect them to the task. So when you run this from anywhere via the command line, you can just add these commands and deploy models that way. It's actually a pretty cool way of making it executable remotely. It fills that pipeline circle, whatever you want to call it. So edit this stuff, connect our arguments when we run it. You don't have to worry about this stuff here. I mean, you know what's going on here. If you've trained a model, you can see the stuff that's happening. And then we save our model and we upload it when we're done. So that's that, really. Now let's look at ClearML and see what's running already. So we have our Triton inference container. Nothing to do here. That's cool, but it's just going to wait for PyTorch models and only those to run inference on. No, nothing else. That's it. So anyway, so this is our stat container. I think Kafka and Prometheus and all that stuff is running that. And then these are our two serving instances. This is our control plane, and this is our serve instance. Our control plane manages our endpoints, which we don't have any yet, and this actually holds our code that holds the pre-processing file. And we'll get to that in a second, but let's just keep working through this. All right, so now that we've, let's look at the document, actually. So if if you're not following along, or you need to, refer to something, just check out the train and publish model train here. So we've done that. No, we haven't actually. Look at that. Missed the whole command. We got to install the requirements. Of course, that's what you do. All right, so first things first here. Well, not first things first, but we're in our directory, right? And then just for my sanity, I'm going to do a activate just in case. We did that. Now we're going to install the requirements. So basically what this is doing is we're installing the requirements in the AI human model. So this is the file. All these. I don't have versions because when I did it, it didn't work. So it seems to figure itself out. Not complaining. But if you can fix that, definitely do a pull request for me. That'd be awesome. Okay, so let's install our requirements. We're good to go. I've probably done this before. So we've installed that. Now we're going to train our model. And this is going to run for a little while. Okay. Let's get rid of that command. This is now AI or human. So we're going to train this, and then what's going to happen is we're going to come back in a couple hours when it's done, and you can let me get it going. So you've done all your configuration, you've changed everything you need. Let me see if there's anything else I needed to do that I can think of that I can't think of. Here we install the requirements, then we just train the model, and that's that. So I write little things in here like the last 10%. That's meaning where you would take toys and take them production. You'd want to run set up ClearML agents for all these models. It's a whole different piece of the pie, but basically it allows you to orchestrate models to be run on different computers. Like you've got a local computer here, you can set it up there. If you've got Colab, which I have and I pay the $9.95 a month for, I just run everything on that. I set up a Colab, I put my I install ClearML agent on there, and then I can orchestrate that from my ClearML UI here and run on Colab, and it's pretty fast too. It's $10 a month, and it never kicks me off, and I use GPU the whole time. Pretty awesome. Anyway, I'll probably do a demo on how to do that eventually because it saves me a ton of time and money. So here we go. So we're gonna get in and train a model. I've been rambling too much, so let's just start running this guy, and then. This is going to take a while, and you're not going to want to do anything until you get this command prompt going again, because it's going to train the model. You're going to see every epoch, and it's stats as it goes. And here you can see kind of what's going on here. Let's take a look at this. See where we're going. So click on this. So these are the things that are happening so far. This is our training model right here. It's kind of neat, right? And what I like about this the most is if you're not looking at your local terminal here, you can just log on to here and check out the console. If you're running this from anywhere else, you can log on here and check out what's going on. Everything that's created within training our model, including our model itself, any scalars or anything like that, data, all that stuff is going to be saved in our artifacts. I save checkpoints; those will get uploaded here, as you will see. So here's what happened here. So what we did was it connected our argparse arguments. So now when we run this from the web or anywhere else we have access to our ClearML stuff, we can just change these. And the really cool thing about this is you could pass in different data sets too. I haven't done it for this, but this is a good way to complete that loop of training. Train a model, get the inference going, train it on a new data set, and then publish that circle. Because when we set up our API, we can set it up to an auto update. So when we publish a new model with a special tag on it, it'll automatically push that to the inference for either regular inference or your canary deployment. But that was a lot of information, so I'm going to just let this run for a while. I'm going to pause the video and come back when the model is trained and uploaded. Then we'll look at what it's done. So just let this run. Go have a cup of coffee. It might take a while. We're only training 1,000 records, so it might not take long at all for you. But let's let this happen and then come back. All right. See you in a few. All right. The model is trained and uploaded. That took longer than expected, right? I mean, it took about 20 minutes to train, but then when it seemed like it was uploading for hours. Anyway, I hope you got to this point where you see, whatever here, and command prompt again, and training completed. You got to see that. Because if you don't see that, that means you close this out too soon, and your model's not going to be uploaded all the way. Sidebar. So I'm playing Prince of Persia, and I'm now fighting the monster Ajata, the big snake. I don't know how to beat it. It's really frustrating. But anyway, if anyone knows how to beat it, let me know. All right, so let's look at what we've done so far here. So we've trained our model, and it should have been uploaded properly. So if we go to our ClearML, we go into our projects, we find our model. I've got tons of stuff here, but let's look at I should have probably cleared all this up before we did the demo, but whatever. So let's take a look at the model project that we uploaded. So models, text classification, and then this. I'll show you things as we go, just to confirm that we're on the right path. Let's look at our config real quick. Models, text classification. All right, with the lowercase here. So Sometimes I screw that up and mess myself up in the process. Cool. So this is our model. It was uploaded. It was trained. Let's look at the artifact. Now this is going to be important here. Always click on this just to make sure it uploaded all the way. I got caught in this a while back where I had closed out my terminal too early, but I saw this here, copied the ID, and just went to work, and nothing worked. Why? Because when you click on this, you have to make sure that the file, the actual model, has been uploaded all the way. If you see files.clearml, files.clear.ml/uploading file, that means it's in the process of uploading and you can't use it yet. So make sure you get a full name here. So let's look at the name. Let's look at our code. Let's make sure it saved the same name. Cool. So we've got that. Now, let's look at, let's go back to here. Okay, so we just went back to our model process. Actually, let's get back there so you can see how we got back there. So I clicked on that, went to our text classification project. We noticed the artifact was there. We verified that. Let's look at the info about the model. Cool. Our configuration is correct. We looked at that yesterday. We looked at the console here. It ran. Bam, bam, bam. Now we can look at something kind of cool. So as we were training our model, we were sending up metrics. These guys. And we can view them here. So at every epoch, we send out boom, boom, boom. It's actually a decent curve. Normally I would send the information every step so you can see a nice curve, but and you can send any metric you want up here, but this is just your standard stuff in your training model. Now let's look at the plots. We were sending out a couple of plots. I think we sent confusion matrix, yeah. So we look at those. So we have 3 epochs. We sent up 3 of these. So there's the first one. Not too bad. Well, it's not. This isn't anything with the model. So this was a small piece of data, overfit, whatever. It doesn't. We're just making sure things work right now. So completed. We're good to go. We can get into publishing models and all that stuff later, but just know that this still works in this state as it is right now. So let's go back to our API and get going on that. Okay, close that out, and now it's time to build our API. So pull up our API.nd, and we're going to look at the ClearML-Serving architecture again. And as we look at our code, we're going to see how all the pieces kind of fit together. Let's first do a quick review of what we've deployed so far. We've deployed Kafka and Zookeeper, streaming, serving, and configuration goodies, monitoring, visualization stuff, the alert manager, and the serving statistics. So when we do deploy our inference containers, we can run stats and it'll all get visualized here if we do so choose. We won't get into this too much today because we've got to build our API. So as we go through our code, we'll look at where all this stuff fits in, where our model is, where our serving session is, and where our things are that we're writing code to do pre-processing, post-processing, all that good stuff. So let's dig in. Okay, so open up 2 files. Go into AI or Human GPT, AI or Human, and open up your pre-process file, and then go into ClearML-Serving, pre-process, open up your pre-process template. Now let's review what we're going to do. We're building our API. This file is a class that we're going to extend to implement all these functions. What's happening here, as you read in the comments, it's the REST API is taking in our data, and our REST API happens to be the GPT that we're going to create. The little text box in there that's taking in our text string. Then that gets sent to pre-process right here. This does something with the request data. So the text is, so you do something with this data, and then this data will be passed to the inference engine. So what you'd want to do here is you'd want to create all the features that you need to actually run your inference. So when you created your model and you did your evaluate and you ran predict, those goodies need to get generated in here. So let's open up our pre-process file and see how we did that. So in our implementation of pre-process, we get our body, which is a text. We'll tell GPT to send it that way. I'll show you how later. The first thing we need to do is generate our features. I'm not going to get into too much detail here, but basically this is all the features for the inference of the explainable boosting machine. This is all the features that are needed to do that type of classification, and those features are returned with our response for the GPT to augment this information, saying here is why we classified it this way. These features had these values, and that means this. So when we get there, I'll show you what that all means. But just note that inside here, there's a lot of code here. I don't want to confuse you. Inside here, we're generating our features that need to be passed for our inference. We would be we're generating two sets of features here. One to be returned, and then one to be called with the BERT inference, our BiLSTM BERT model. And that right here is our tokenizer. We clean up our text. These are our tokenizers that we used. Our tokenizers that we used when we trained the model up here, and now we're reusing it to pass those inputs directly to our Triton inference server. All right, so once that happens, the request comes back. Now, if you look at evaluate or anywhere, in model inference, you get a bunch of information back from the Triton server. You get the input IDs and the attention mask. Now, what you need to do is you create a series of tensor outputs for that. That was a lot, but basically you're returning those tensors here, I believe, or NumPy arrays or whatever they are. They're numbers that get passed into the post process, so we can run our argmax on here to get our number out of these probabilities. I went ahead of myself, but that's cool. So post process here does something with returned data from the model inference. We are taking our model inference information as BERT outputs, inputs, attention mask, BERT outputs, running our inference, and then returning this back to GPT, the API. So we got our BERT predictions here, which is just a 1 or a 0 for now. We could return probabilities, and we will, but we're not. We're just going to do 1 or 0, make it easy. And then all the features we would have used to do the EBM, the Explainable Boosting Machine inference, which would give us a probability that we would average with the BERT probability and create a better number than just the BERT number. However, we're not doing that we need to create another API, and we don't want to do that. We're just going to use the 1, but we're going to return those features back to the front end. So we've got features, and then we've got our BERT predictions. What we're going to do now is we're going to test this to make sure it works. I think it does. I'm gonna assume it does because I've ran this before. But what's going to happen is it's going to run through all these goodies, return our JSON file, and then once we do that, we could set up ngrok, run that, and then build our GPT to sit on top of this. But first, let's go back to our terminal, and we are going to first test our, not that yet. We want to, let's go back to our document real quick. See where we're at. Next in line, we review the API and what we're doing here. Bam. Now we run our test. Okay, so it's a little scary. I'm going to do Python 3 just to make sure that I'm running in my conda environment. So we are running. Let's look at the test real quick before we run it. And this is the actual first try. So let's see if it works. So we're doing something real simple. So we're running this through our generate. So now we're testing our API. Sorry, we're just testing our feature generation. This is important. This is the other complex thing. We run our inference, and then we run all these functions here. We go through this good stuff here. All this code we got to run and make sure it works. But I know it does. Let's get back to it. Let's run it and see what happens. So we're passing in just a text string. This is, I'm rating you today as a concerned citizen of your state to express my strong blah, blah, blah. It's nothing. It's not an essay. I guess it is an essay. So I think I had GPT do this. But anyway, we'll see. We'll look at the response if and when it works. So first things first, let's run this test. and we'll investigate our response, and you get to see our entire feature matrix probably for the first time. It's taking its sweet little time. Don't get nervous. All right, so it's calling the function, blah, blah, blah. It's doing all these goodies. Let's hope it works. It's running our inference, or it's not running our inference, and it broke. Good sign. Oh, look at that. We are not running inside of our Conda environment. I'm going to keep running this because I think this is good to know. Actually, very good to know. 100% good to know. Let's first look at what our let's see what we're using first. Do which Python. Errors are always good to run into. Bam, we don't want that. So we need to do this. Go on the list, see where we're at if we even run it. Wrong word. I'm lit. Okay. Oh, we see the environment list. See if we're even running on the right one. See if we're running on base, any kind of 3. No good. We need to get in 539 demo, right? So, Conda activate 539 demo. Now, let's try this again. Let's make sure Python, at least 3, because 3, sometimes you got to do Python 3 if you're running in Conda environments, or pip 3. It's weird, and sometimes, and you can map Python to Python 3 command if you want, but okay, so this is important. That's good. So now we can test for real and see if it's actually all broken. Okay, we are definitely running inside our environment that we set up. So if this works, that's cool. That means all the packages you installed will work for the at least the feature generation. Takes a little while. Loading. We're using MPS. Look at this. I think it's going to work. Bam. All right. Good sign. So here is our feature matrix. We are pulling all these goodies. These are all our statistical features, and this is all our empath Lisp features. I'll get into that later. I don't know where to start now, but these are, for the most part, the things that are going to be used to describe the response, the augmented retrieval, blah blah blah, the augmented what is that word? Retrieval Augmented Generation or something like that. but this is what's happening is these features are what we're going to pass through the GPT API, which is the GPT large language model, and by taking this information, all the how we describe these features, and they'll be able to, and it'll be able to craft a better response to show why something was classified the way it was. Okay, so next, let's go back to our diagram. This test worked. That's a great sign. Great sign. So now is the fun part. What we're going to do here is we're going to orchestrate our model. This is wrong, which is good because we're going to fix it all, and I'll show you what we're fixing. So in this command, we are adding our model to our service. Let's start over real quick. So let's look at our diagram here. Okay, then we have our model repository. We have our serving sessions running as well. This is good stuff. This is important. So, and this is ClearML server. This is the web, the ClearML is what the API stuff right here. ClearML server. So we go back here, and now we're going to run a command to push our inference code that we just wrote here to our inference container in order to serve up our inference and make it work. Now, Let's go back to that command. The first thing we're going to do is we're going to want to get our ID. Fill down. We're going to want to get our ID from our serving service. So let's close out of here real quick. Let's go ClearML-Serving list. Now we're going to find the one we created. We should have that number written down, but that's cool. So I didn't delete all the other ones we created in all our tests, but remember the last one we created was the AIOHU demo. Let's make sure that's correct. OIHOU demo. I'm sure you can get the numbers from here, but I like getting them here for the most part. So we're going to copy this here. Actually, let me go back to this right here. Okay, so ClearML-Serving. This is our service ID. We're adding a model. Now, we can also do model auto update. I'll get into it real quick, so I don't have to explain it later. What auto update does, it allows you to push your preprocessed file, which is the file that we just created, and auto update the model. So what happens is when you push a new model with a tag and or publish the model, that inference container gets updated with that new model. It's good for like canary deployments. Say you want to push a new one, bam, you do a canary on that new model. That way you can be testing two different models on different things. Or that actually wouldn't work for auto update. You'd want to do an add and then do canary on that. But anyway, we won't get into that orchestration stuff right now. We'll look at exactly what we need to do for our project. So what we're going to do here is we're going to add our service ID here, and then we're going to add the model we're going to use. So let's go back here and let's just make sure we're going to use that exact model that we trained and deployed. So text classification, we have one success here. We have an artifact here. We have a model. We have a model ID. Let's copy it. So it's copied to clipboard. Go back over here. Paste that in there. All right, so here's what we're doing. Adding the endpoint. Now the endpoint we're going to use is the BERT infer demo for inference demo. So that's the endpoint we're going to be calling. The pre-processing file that's going to be doing all the work is here. We made that happen. Boom, boom, boom. We tested it. It returns the JSON file the way we want it to. Okay, and then these are just properties about what we're passing in. The information that can be passed in, the input size, the input IDs. These are the properties that we're going to be using in our inference container. But nothing. This is not super important right now, other than know that this works for a BERT model. We're going to run this and see what happens. Oop, not like that. We're going to run it, but we're going to run it like this. And let's see what happens. This is an exciting part because now we get to really test it. All right, so this takes some time. It takes about 5 minutes sometimes to update. So let's see what just happened. And this is cool. This is the cool part. So, okay, head back over to ClearML. Check out your projects. Go to your DevOps project and experiments. Find the serving control plane for our demo. Look at the endpoints and see that we've deployed it. Cool. So engine type is Triton. Our URL is BERT info demo. That's what we want, demo. And then the model ID is the one we put in there. So we're good to go here. And let's look at our pre-processing code, because that code is going to be processed when we pass in an input string. That code is here. That should be the same file that we uploaded. It is. We know it is. Because it's the only one up here. Let's take a look at our serve instance, because this should have our information to pre-process, or not pre-process file, but do the pre-processing. That's one of our models and one of our feature generations, and that's another model and another of our feature generations. So that's a good sign here. So when we run our inference, the pre-processing can be done properly. So I guess now it's time to test our API. This is the URL we're going to hit first. We're going to make sure this works off the bat. So we'll first test it in our code. We'll run a little unit test here. This will just give it a quick whirl here with a text sample. Then when we test it here, we'll test it in curl. And then, I also uploaded a Postman file so you can test it all in there too. But let's run this one first. Okay, so actually, let's just run this one because it's the same thing, but actually, no, let's run the test. So we're testing the API. We're going to run it and hopefully get something like this, which is our prediction for the string, and then all the features that are being generated for the forecast and for the response back to GPT to make it sound really cool when we give them you were generated by a large language model. So it looks better to the end user, obviously, if it's explained why. And obviously ours is not going to be right or wrong in any way because we only trained it on 1,000 records with a model that doesn't really do anything right now. But this takes a while. Let's look at what's going on behind the scenes while we're doing this. So things should be happening on our server. We could look at this two places. We can look at our Docker containers because that's where our stuff is running, or we can look at our project in here, in our DevOps project. So we have our serve instance. We'll go to consoles here and check them all out and see what's happening. Kafka, no big deal. It's going to have errors. We're not passing any stats over that way. Things are going to work good. We need the Triton. That's what we want. So we want to see if this got called, and it did. So we download, fit the endpoint. Let's check here now. See if anything happened on this end. Nothing's going to happen here. Our serving control plane. Download the model. We should be good to go. It's probably running for the first time. It takes forever. No. Did it run? Yes, it ran. Okay, good. So we got our data back. The response from that test was that was written by a human. And I know for a fact it was not, but it doesn't matter. We know our model's not working, and these are all our features that are going to come back. So that's a great sign. Let's do a quick curl test as well, just to see if it runs any faster. I don't think it will. Speeding it up is so it's just something that's not going to happen on my computer, but when we actually deploy this to the world, it will. And after we do this, we're going to set up ngrok and test that URL to make sure that's good to go. And then once we're done with that, we'll close this little section out and then go and build our GPT with this inference and see what happens. This is going to be fun. But let's make sure all this stuff works, set up ngrok, test that, and move on. So give it a second here. Let's see if we can find this stuff running inside Docker, just for the heck of it. Let's go to our inference here. Log, see if anything's going on. Just a lot of stats that are not being reported over to Kafka. And it's like things aren't breaking, it's just not, this must have been an error earlier. This is cool, we can always go back and see what's going on here. So good. Ran, pulled all our, okay, oh, this is good when we, this is all the stuff that's happening when we run our feature generation. So this is that model that we're actually seeing, that PyTorch model that I've talked about. That's it. So let's see if it worked. And if it did, wrong terminal, still processing. This takes a while, but the feature gen takes a long time. There's a lot of information that gets processed. And when it's running somewhere else, if it's running on a GPU, it's just like that. So that's just life. But I'm pretty sure this will work since our test worked, and we're doing the exact same thing. We're calling that. But I want to see it run. I want you to see it run. And that way we could go to ngrok and test the exact same thing. Speaking of which, in the meantime, let's go to ngrok and see what we got going on here. You've already set this up. You do it from the command line. It's no big deal. You just do ngrok. I should have an endpoint already set up. I do not. So let's set one up. Let's create a new tunnel. We're going to do 80. So let's go into here. When this runs, I want this response so I can move on. Let's look at the code that we're going to be doing next. I don't want to pause it because I want to make sure all this works. So it's our test and Postman, moving on, but now I want to test the ngrok too. Just make sure this ran. Oh, good, it ran, it worked, good. Same stuff, 0, it was created by a human. I know that for a fact it wasn't, but all good. And there's all our features. The types of features I won't get into now, but these are a lot of scores and a lot of statistical stuff. And these are a lot of like empath things. And actually, without having to get too much into it, make sure that you read this whole notebook so you'll understand why the features are generated, how they're generated. We can actually talk to our, you know what, we'll get to that when we get there. I don't want to get ahead of myself. So that's working. So we tested that. So now let's do our ngrok. Create our tunnel. So we don't have it here, but we already know what to do here. So we're going to do ngrok. HTTP, that's what we want to set up our tunnel for. Okay, so that's what you're going to type after you've installed ngrok, and it's going to create a URL. And then that URL is now going to be our API. All right? So cool. So that's our public web right now. So we're going to need this. Important. So now we're just going to retest. Retest. Did I just do a curl? Yeah. And we're going to put in our ngrok here. Now there's one thing you're going to need to do, and we're going to do it from when we call our API. We always need to send this, and we'll tell our GPT to make sure this is sent. But when you use ngrok, you get a browser warning, and that browser warning will stop any external API from moving forward, including our GPT that we're going to be creating. So make sure this property is sent anytime you hit it. Ngrok skip browser warning, and you put any value in there, it doesn't matter. I just put 1 because, yeah, theoretically 1 means yes. So we're going to test this now using our new, make sure that's right. So we're posting text, that's the string it's looking for. So we're going to run this, and when it does work, we'll pause the video real quick, hop back on, do our GPT, and call it a day. That's going to be the exciting part. And oddly enough, while that might seem complicated, it's the easiest part of all this, because this is the magic behind the scenes, and that's the magic in front of the scenes. But let's run this real quick. It seems like it's working. Let's run back over here. See if anything fancy's happening here. See if Triton is picking up our inference at all. It's still doing nothing, which is good, meaning it's not erroring. See if this, okay, Kafka's always going to error because we're not passing anything to it. Right now, this is doing its thing. Okay, so I probably need to reference a local model, actually, to download only once and not every time for inference. We're not going to do it for this demo, but see, I did not do that. I think I might have taken that code out. So now it's going to download and run the inference every time on a downloaded model. That's why it's taking so long. Will not fix it for this error, but it's good to catch things like that. And we couldn't have not caught it. But while it's a little embarrassing, I'm going to leave it in there for good measure. So let's test. Let's make sure this works. Come on, please work. All right, so it worked. Good. So now we can pause, and then we'll come right back, and we're going to build our GPT and call it a day. Cool, thanks. This is exciting. All right, bye. This is it. We get to make our GPT with all the work we just did. I hope you went through all that, because that was a lot of work to put all that together. But it's all going to pay off when you do this, because the response that we get, we're not just telling somebody that we think your essay was written by a large language model, or you probably wrote it yourself. We're telling you all the reasons why that model determined what it did. I know technically it did not, because we're only using the BERT model classification and not the EBM, because we didn't want to set up 2 APIs for our demo. However, they will be in an ensemble, averaged out, and then everything else that we're returning with all our features and everything is getting it interpreted by the GPT and returned back to our user. Good stuff. Beyond that, Beyond that, I'm going to use this for every single API I create from now on. It's a test harness. You hook it up, and you'd be like, think about it. Think about if you're testing data or testing an API that you need to send, 1,000 records to hit it, and then set a bunch of errors. Be like, break my API, and then it'll do the best it can. It's anyway. I could go on and on about what the large language model of GPT can do as an intermediary between you and your API. Beyond that, let's start making this. So click go here, blah, 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 GPTs, and then create a new one and get going here and follow me as we go, because there are some nuances. There's some things that are quirky because this is a brand new product. It just came out, I think, a few months ago. The API got released in beta, and the GPT store just opened up a couple weeks ago, and I've been for 3 months been developing all that other stuff, just to get this going. And I actually didn't have the idea to use this until later on. I was like, well, let me see what I could do with the endpoint of that API I was creating, and or that model I was creating. I was like, well, this is a great idea. But anyway, so let's get through this. The obvious stuff we're not going to fill in just yet. It's not that important. Actually, it is. Let's name it. Go AI or human demo. And as I type, I'm going to try to explain some of the stuff we need as we need it. I could do an overview. You know what? I'm going to. There's a few things that we're definitely going to need. We're going to need instructions on how this GPT creates itself. We're going to need a knowledge base. That knowledge base, it's called knowledge here, but when I was talking with GPT to be like, how do I explain things? What words do I use to describe certain things? It kept using the word knowledge base. So I think it refers to this knowledge file as its knowledge base. Whatever that means, I'm not sure, but I use that word. That file basically describes how to handle a response or how to interpret your input. Say you're looking for just, say you're looking to create a GPT that wants to, solve equations. So you write in your language, 6 + 7 + 2 - 8, go get 5 cars and, pull all the parts out and how many parts are plus the add we did, whatever. It doesn't matter what that is. It was a horrible example. But what it would do is your instructions here might be take all the natural language that gets processed and put it into an equation. Make sure you respond in latex when you respond back so they can see the equation. All that good stuff is how they handle your input and how it handles what it looks for on the back end or your response from an API. That'll all make sense as we do it, but I probably explained it horribly, and I don't want to ramble too much. I want to get to work on this. So this is AI human demo, AI or human SSA. I just want to put toy here. I don't want anyone to think that this works the way it should. It can. And, with a lot of data and a lot more work on the models that I made, probably, read the notebook and you'll see how this can and will be improved. And it is improved already. This is just for the demo. But I don't want anyone who uses this, if you decide to make your stuff public, don't let them know that this is actually classifying anything in any way, shape, or form, because it's going to be wrong. But for us, it's a great way to, look at the API and see how it handles the response, because those numbers won't matter whether it's, the BERT prediction is what you really don't want to give back. You don't want to say yes or no. We want to give back the reasons why it could have said yes or no, and whether it was written by a human or an LLM, and all the reasons why it made that classification. That way we're going to try and kind of fingerprint an essay in a sense, and be like, these specific statistical features of an essay, how many trees and this and that, and we look at all the features, make this possibly created by a large language model. Not the content so much. You don't want to get into content, because then it gets nasty. And obviously this is only for English for now. I haven't tested any other languages and not going to yet, so that's a good disclaimer. But because it doesn't actually look at the content of data, it doesn't look for plagiarism, it doesn't look for any of that. I don't care. Unnecessary. Don't want to do that. We want to look at just mathematical numbers that can be created. Some of the scores, like the standard the SMOG, the standard measure of gobbledygook, that's actually an equation. So those like eight or nine features that I create are pretty standard in measuring an essay text or written text and how it does its stats. They're all listed there. Check them out, read them. I've referenced all of them all. But everything else is just stuff I came up with to basically try and fingerprint, or me and my research came up with, and how to fingerprint a written text to maybe see it was written by an LLM instead of a human. But that's to be determined later on, when we actually get into the model. This is more of an engineering study, less than a data science and AI study in that way. Okay, so the instructions we give it is what it's going to do. We're going to read those and put those together. Conversation starters is just, the things like, what do you want to get going? Here, we'll put in one, classify this essay, or how do you work? That'll be like, how do you work? Or, how do you, ask me for my age. Ask me for an essay. Ask me for an essay. Yeah, that's one. We could do another. Yeah, this was cool because we were going to give it all the information to so it could give quality responses to how we generate and how we built our model, including the code. I don't want to hide anything from anyone. Like if you're gonna start to dictate whether something's been written by a human or a large language model, you better tell them exactly how you came up with that, because otherwise, what's the point? What are you going to say? Oh, you can't write? It's ridiculous. So if you say anything like that, you have to explain the equations and the models and exactly the data that was used to train the models and all that stuff. So we're going to give it all that information, because when people ask, why did it classify me this way? What kind of model are you using? We're going to be able to get in and spit out the code for our BERT BiLSTM that we created, as well as the EBM, how it created, and all the data that was created, all that good stuff. So this is really just open everything. Literally open everything, including the data that was used to train. You can check it all out. And it's not that difficult to do, as you'll see. So let's go. So I got off on a tangent there. My apologies. So we're going to get into all this. Ask me for an essay. Our knowledge file gets uploaded. We create our action here. So we're not going to do anything more than this yet. All right. So let's go back to our project here, and let's look at the things we're going to need to make this happen. Close everything out just so you don't get confused, anything else, and go just to our GPT. Right here, you got our knowledge file, we got our privacy policy, we've got our Swagger. Don't even worry about the privacy policy. You do need it when you test external APIs, or when you put in actions that call APIs. So I'll give you a URL to put in. It's for this project. We'll deploy this. This is on the GitHub repo that you can just link to and put it in there if you want to test it. Or you can deploy this another way, get an ngrok to this, whatever. But you can't be localhost, and it has to be online somewhere. This is the Swagger. Let's get into this. Let's look at this first before we get into what we're going to tell the GPT and how to act it's that way. So these are the things you're going to want to change. It's only one thing, actually two things. I'm going to leave this broken for a reason. I'm not going to change it. Just because I want you to follow. Not want you to follow, but I can't have everything just go right, because you'll never learn anything. Neither will I either. Something's broke. That needs to be changed to BERT for demo, because that's what we set up when I was tested locally. And you also need to change your ngrok URL. So let's just go back and check on that. Make sure we're good to go there. We have an endpoint. We should have an endpoint. I know we created one. We could have done this with the command line too, but we don't want it. Let's copy this. This needs to be put into our config, because our API is going to be calling this URL. If you had it deployed somewhere else, put it somewhere else, obviously. And it needs to go to serve, because the endpoint is just, this right here. And this is the ngrok tunnel just to here. 8080. And then 8080 needs to go to serve and this. So make sure this is all written like this. Give it a description. And this is just your standard Swagger markup. Don't do much more than this. And I'll tell you why. You might be tempted to go in and add all the response information, this, that, and get really complex in how you want it to handle your information. Don't do this, only because I tried it, and it's not. I'm not going to say it's buggy. It's just it gets complex that way, because you're going to tell GPT how to do everything, and it's going to handle your information, process that in its own natural language, and store that information itself without you having to tell it a whole lot. Other than it's going to know the JSON that gets returned. We're going to put that in here in our knowledge base. But this is all you're going to do right here. Nothing more than this. So let's take this file and create our action. And our action is the thing inside our GPT that is going to call an API. So create a new action. let's just paste our schema right in there. You don't get fancy, don't use their examples. Just trust me on this one, it's going to work this way. We don't have authentication yet, but you can use it. We could easily authenticate our local host this way, but for the sake of this demo and to make it easy, boom, look at that. What was wrong with this? Cool, so that's wrong. How did it come up with BERT infer when it's infer demo? What's this? Oh, there it is. Never mind. But the path, did we do the path wrong? I think we did. Look at that. See? I screwed myself up. So we want this to work. We don't want to test it yet. Trust me on this. If you test it, it's going to make you feel bad. So don't test it. Let me get the URL for my privacy policy. Hold on 1 second. It's not on my computer here. But give me 2 seconds. I want to do this in real time. Trust me on this. Edit this. Sorry. Action. Wrong one. I'll edit this out probably. Maybe I won't. I don't know. It's going to take a second. Bear with me on this. I just got to get the privacy policy URL. I wasn't ready. I don't want to go back and do all this. Again, this is the cost of a live demo. Sort of. Even though it doesn't have to be live. Okay, sorry about that. But here's the URL you're going to put in. This is just a demo that I set up somewhere. And we're going to save it. We're not going to test it yet because it will break. Trust me on this, it will break. You have to save this every time. So, good to go. Test, save. We don't get anything red. If this was wrong, say this was localhost, it would break. If this was localhost, it would break. Watch. Just for the heck of it, let's put it here. Bam, don't like it. You don't want any of that. It's not, it'll never let you work that way. So let's just go back to our URL. I think we changed that, right? Or did we pasted that? Okay, good. So let's save it. Only me. Save it for yourself. Don't put this anywhere. Not yet, at least. All right, so it's not broken yet. So now we're going to edit it. Now, we're going to, let's test it first. No, actually, no. I'm going to get ahead of myself because we're going to get nervous. Because we're going to first now do our knowledge file. But before we do that, let's look at it. So our knowledge file here is a lot of information. This is everything that the GPT should know about our response and how to handle it, and how to reply to the front end, and how to handle the response. This is literally what is it? What am I looking for here? This is why am I lost? It is, oh, that's it. The Retrieval Augmented Generation. Really good stuff. This was the idea behind this, and what was the name of the paper? I read it. We all read it. What was it? Let me find this real quick because it's important that I credit this paper because I know everyone loves it. It's the where is the writer? The writer was Lewis, I think. Yeah, Lewis et al. That's it. The paper was written a long time ago. The thing was called RAG, and the acronym for Research Augmented Generation. And basically what it is it's the idea that you go out and retrieve a document of some sort. And our document retrieval is going to be the JSON file with all the statistics that were used to generate our inference. But then you run that, you dredge it through a large language model, all right, and then you get your response back. That, in a nutshell, is what this is. I didn't do it justice. Read the paper, but you know that's what that is, and this is what that is. So this is what we're going to paste into the instructions. This is how we handle the response. This is everything about our project. I'm not going to bore you with this right now, but read it at your own leisure. It talks about the model, the hypothesis of everything, the code, and how to do stuff. Every single feature that we have in here, every calculation and every piece of code that is used to generate every single feature, so people can ask about every statistic we have, every model. We have the model architecture, so people can ask which model did we use. We used the BERT, and we slapped a few layers on here like this. And the rationale behind why we used it, the architecture, blah, 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 the code, the literal code that we used to generate this. This is the fancy stuff that I did, not for this demo, but this is the good code. Then we did the EBM. What is an EBM? All that good stuff here. I know it's a lot. And then the actual code for that and how it handles the response on that. More information. Here's how it could handle response. That's a picture of me. I'm not sure why I even put that in there, but whatever. Some more information about the response and some references, and it's a lot of data, and it's good because it's going to let our GPT take our just static numbers and turn them into magic. So let's go back and make some magic again. So here we go. So we're going to upload a file, and we're going to upload the whole thing. I know that, let's see here, we want to get to me, demos, all those files. I need to clean up my directory, and where was I? GPT, our knowledge file. And then we copied a set of instructions for our knowledge file, and we're going to paste those right in here. Here are GPT, the AI or human, specializing in blah, 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 blah. Let's add an image too. Let's upload a photo. We want to upload a cool picture. We did a... have you watched the Monarch? And the first episode, they had the signs of, it was like Godzilla Hazard Zone in Japanese, and a picture of Godzilla in this logo. I love it. I want that. I love that. I just love the design, the idea that you go somewhere and see Godzilla's picture, and watch out. Anyway, it's funny, so I did it with a cat. And so here we are, blah, blah, blah. We're going to save everything. Nothing's going to work yet. Update it. Trust me on this. Confirm. Now watch this. We're gonna fix our misspellings. And now let's go to create. I know when I saved it a bunch of times, anytime there's unpublished changes, no matter what they are, just save it. I've run into issues where I thought things were going to be broken and they weren't. I know you want to test this so bad, and so do I. But let's go to create here. Continue where we left off. We haven't started. Let's paste our instructions, see what it says. This is just in case, this was just another tunnel software, but don't worry about that. See, this is the Embark browser, so it works. This may not work the first time, it probably won't, and we'll have to go in and configure it, and I hope it doesn't, so we can do the configuration. But let's see what it says. And when it doesn't work the first time, see, this is kind of behind the scenes stuff. I don't really know everything's going on. I wish I did, but I think it just updates our instructions in the configuration, but I think it does more than that, which is how do I assist you further? I'd like to test it, but not yet. If we have unpublished changes, we're going to update only me, and it may break because sometimes you have to pass this 2 times, but let's test an essay. Generate an essay and test the API. Let's see. Right, this is how we test data. So generate an essay about why cats think Godzilla is cool in 300 words, and test my API. And test my API with that data. All right, let's see what happens. If this works, this would be so cool. So draft an essay, process. Look at that. How cool is that? Yeah, it's really great. I sure might find Godzilla intriguing for several reasons. Size and power. I know this takes longer than usual, but I don't know. It's fun. It makes me laugh to read this stuff while I test the API. It makes it all kind of worth it because all the stuff we went through, it's a lot of work in there. So when you read stuff about Godzilla and and cats, it just makes me smile. So let's see what's going to happen here. You should get a little thing that says testing your API. Hasn't happened yet, but it will. And then we click OK, and then it runs the request, and then we'll look at it. And if I'm almost nervous because it's so exciting to see this stuff work for the first time and to check out the response. All right, so let's see. Should be calling it our action. Sorry, our action. Fingers crossed. And we'll check out while it's testing in real time. So it should say now calling our API. Let's hit OK. Fingers crossed it's working. Hopefully we put everything in the action right. There's definitely going to be something we might have left out. But I might have tested everything. Just let it do its thing. I'm nervous about the unpublished changes. Oh, good. Oh, wow. So, okay, so it hit it. It's hitting our API. It's got our privacy policy. Let's let it go. All right, fingers crossed. Talking to our, ooh, look at this. Getting nervous. I hope you are too. I hope you made it this far. I hope you're at this point. You did everything you needed to do to get to here. And I hope your API replies with a cool response. It should, if it works. I want to see it just work. I don't want to test it yet, but we could go to our, online and see where it's going, all that stuff. But I just want the response to come back, either broken or not. If this breaks, that means the response it'll just go to plus, or it'll just go to send a new thing without a response if it were to break. But I'm thinking this is going to work because we tested everything, and all it is calling our API. Okay, so let's see what happens. Let's see. This is good. I said it wasn't going to happen the first time, but we'll figure this out. So let's first check out here. We want to go back to, our endpoints here. Let's check out here. See if we even got a call. If it didn't get a call, then we probably didn't run our inference. Smaller relative. Okay, it did at that time. It said. Let's look at our URLs, make sure everything lines up. I'm hoping this is just it. Sometimes it is. So we copy this. Go back here. Go to configure. And I may just not have saved it before I test. This happens. But this has never worked the first time. It just won't. It just doesn't. Let's paste this in here. Alright, we're going to save it. So we updated the endpoint. We're going to update this. Confirm. Okay. We're just going to go back out of here. Changes. Create. Update GPT. So I updated the configuration, so it'll update, and then I'll save that, and then we'll test it again. Fingers crossed. Okay. Okay, cool. Let's save it. Maybe we did do that last time. Hopefully I did. Let's just refresh. I want to test from scratch. Let's get an essay that worked from our curl command. Not that it should, but not that that should matter. It really should. It definitely shouldn't matter. What's this? It's a test string. So we'll just pass a little string in there. Make sure you get a response. Please test the essay with this. Please test the essay with the same with this text. Okay. Please test the API. Sorry, I'm confused. So this one will or will not work. Fingers crossed. Let's see if we're getting. Okay, good. It's a little faster. This feels good. So I feel better about how the speed here. Might have downloaded the model, might have broke, might have hung up. Sometimes it takes a little moment to do this the first time. We didn't really change much. Maybe we had the URL wrong. Who knows? Let's see what the API is telling us. I have a feeling it's going to work this time. not hitting the API. No, that's not it. Let's see if it's here. Just want to know if that's our issue. I should probably have been prepared a little bit better. Figured it out. It's exciting. But remember when I said that don't worry about Kafka. It can find its it can error all the time. It'll recheck and it'll work. Well, guess what? I was lying to you. so actually, I figured it out really quick right after I stopped the last video. But then I ran out of dev time with GPT. GPT-4 only lets you do so many calls, and then once you do too many calls, it stops you. So I had to wait 2 hours until I was allowed to develop on their API again. Not their fault. It is what it is. It's a brand new product. So anyway, so here we go. So we started Kafka up again. We're going to test our GPT. I know it works. I just tested it, but let's do this. Let's test the API with an essay about cats and why they eat. Mice. Yeah, well, like, eat mice. We'll do a 50-word essay. Real straightforward. Okay, so let's see what happens. And I changed the image out, but don't worry about that. That's neither here nor there. We just want to make sure this works. All right, so we're calling our API. I just want to get a response, but fingers crossed this is going to work. Now let's see what it's calling. Okay, that's our ngrok stuff, our endpoint. A mice eat cat due to instinctual nature and predator. Oh, look at this. Hold on. Oh, good. So, okay, here we go. You can see I'm smiling because it's actually really cool. Okay, so let's look at what it gave us back. The analysis of a brief essay about cats eat mice using the... Oh, and it tells us the model that it used. Very nice. Returns an interpretation of 0. This is here's a breakdown of some notable features of the analysis. Really cool. Check this out. Oh, I got to bold this stuff out. And this is just the feature groups that we use, but linguistic diversity. We'll have to bold this so it makes sense. And that's all the stuff in the knowledge file that we can I spelled it wrong, that we could change and get that working. Minimum APIs, blah blah blah. Content. This is really cool, actually. How awesome is this? It just makes me smile. Straightforward. It is cool. All right, so let's check out some of the stuff that happened before we call it a day and have some fun. Okay, so actually have some fun, but just be done with this because it's been a long one. But I hope you sat through it and went through the whole process with me. Okay, so I guess there's really not much to look at. We saw that we called our inference container here and ran our predictions and returned all the features. All good there. I wonder if there's anything else I need to do. And I hope you get it working. If you do, definitely leave me a comment or something wherever you're reading this, or clone the repo and let me know what you did with this code. But I hope it worked. Remember, always update your changes here all the time. And if it doesn't work the first time, like we just ran into, just get in and dig around. You're going to find something that's going to be really straightforward. It's funny that the thing I thought wasn't going to be working hours ago when I kicked this up, this wasn't finding the endpoint. And I was like, well, it'll find it eventually, and I left it alone. And then it worked. Remember, it was working with our curl commands and postman, but did not work via the API. So we're going to call it a day. Thank you so much, and let me know if you like this. But have a good one. Take care. Bye bye. Hi, my name is Michael Lange, and today we're going to be developing a custom GPT that communicates with an API that you've developed. What are GPTs? GPTs are the new technology by OpenAI that allow you to slap some of your awesomeness on top of the ChatGPT platform. Today we're going to be setting up ClearML for our MLOps, an amazing tool. We're going to be training and deploying our models. We're going to be developing our API with ClearML-Serving, which uses NVIDIA Triton inference containers for our PyTorch model inference. Return it all here to the GPT front end and allow the GPT to interpret and explain the forecast that your models have given it. All right, that was a mouthful. Okay, so what are we doing here? What this GPT does is it analyzes a text string that should be a human or AI generated essay. The idea came last year when Kaggle released this contest called Detect AI Generated Text. It was sponsored by Vanderbilt University and the Learning Agency Lab, and I got to thinking, it was like, this is a tough one. Anytime you deploy or give automated judgment, because we're basically saying, that your hard work was generated by a large language model and not by you. You got to explain why, I think. OpenAI, I know a few years ago, developed a tool to determine whether they whether their platform was written by, or whether a string was written by a large language model or a human, same idea. And I know they took it down. I'm guessing it's because there was a lot of false positives, right? Like I said before, false positive is really destructive in this scenario, because if you worked really hard, and what does false positive or what does positive even mean in this case? It's not like an image. An image either happened or it didn't. You look at an image, it's fake or it's not. The ground truth can be subjective in the sense that, you're going to make a determination whether before you find the ground truth. But with an essay, you've got the idea that you've rewritten a lot of things for using ChatGPT. That's what I've used it for the most. Come up with some ideas, be like, here, put this together in a cohesive paragraph. And it does it. Is that rewritten by a large language model? Technically, yes, it is. But is it subjected? Should that be subjected to, you didn't do this work? I don't think so, actually. But so the compromise here is you got to explain why there's a forecast. And I came up with a bunch of features, statistical features for the most part, that can fingerprint an essay and determine whether it was a large language model or human. But even more, using those statistical features, allow a large language model to explain that forecast. And that is called a retrieval. Retrieval Augmented Information. That is the acronym's RAG. It's by Lewis et al. It was a paper that written a couple years ago on this concept of going out, getting a document somehow, and ours is going to be the feature set and the forecast, dredging it through a large language model and letting that explain the response. It's something like that. I don't want to explain the paper. I'll let you read it. It's a great paper, but that's the idea behind what RAG is. Anyway, here's my notebook. I'll let you explore this on your own, and the code for all this is in here, and it's in the GitHub repo that I'm going to provide when I do the demo in the next few lectures. Let's first test this, make sure it all works, because this is what you will be developing. So what we're going to do here is we're going to generate a 50-word essay on GPTs and test the APIs, so I don't have to write all this. So let's, son of a gun. Look at that. It's not even letting me develop. I'm going to use this.